All right, today we're going to review for a quiz slash test that we'll do on Alex tomorrow on Friday. The quiz test will only be available on Friday. It will not be open any other time, so it's only open for one day, and you only get one chance per question. Okay, so you want to make sure you're using a piece of paper, work everything out before you decide to answer the question on Alex. Okay, very important that you do that. So you only get one chance per question. Okay, I'm going to review with you the type of questions that will be on there and have you do some of your own after I've done one. If you would like to stop the video and do a couple after I go through the example, that would probably be good. Make sure that you take any notes you want to take, and you can use those notes on the test tomorrow. All right, let's get started. So the first question we're going to have is going to be graph the line by getting the equation of y, the equation in y equals mx plus b form. So you're going to start out with an equation in what we call standard form, having the x and the y on one side and a constant on the other, a number without a variable. What you will do to get it in the correct form, y equals mx plus b, notice in this equation, y is by itself with no number in front. That's the key. I want to get the y by itself with no number in front, starting from this form. So how do I do that? Well, just think about getting this y by itself. What's on the same side of the equation as this y? Well, there's a 3x and there's a 2. You always want to get rid of whatever is being added. See, the 3x is being added to 2y before you get whatever is being get rid of whatever is being multiplied. The 2 is being multiplied to the y. So get rid of addition and subtraction first, then get rid of multiplication and division. So I do that first by subtracting 3x to both sides of the equation. Whatever you do to the left side, you got to do to the right. Now that leaves on the left side 2y. Subtracting 3x over here, these can't be added. Don't write 12x. I have some kids who will do that. Remember, there's no x with this 15. So these are two separate terms that are not like terms. These are unlike terms. So I need to write the negative 3x plus 15. So 2y equals negative 3x plus 15. All I've done is subtract 3x to both sides. Then I divide both sides by 2. Now, this first term you want as a slope anyway, so you want it as a fraction. So if it turns out as a fraction that doesn't reduce, just leave it that way. That's fine. Fractions are good on this when we're going to go to graph them anyway. So I'm going to have y equals negative 3 over 2x. Now here's the problem. Most kids will do that, and then they'll forget to divide the 15 by the 2. Don't write negative 3 halves x plus 15. Make sure you divide 15. Also, both terms have to be divided by the 2. So 15 divided by 2 is 7.5. Now I go to graph it. So I go up 7.5 on the y. Do not mark your x-axis first. Mark your y-axis first. And the value that is being added or subtracted in the equation is what you want to mark first. So in this case, it's 7.5 or 15 halves. So if I go up 7.5 on the y-axis, that's the first point I mark. From this point, once you're in slope-intercept form, you just simply follow the slope. This says I'm going to go down 3 units and over 2 units. The up and down is on the top. The right and left is on the bottom. Let me say that again. The up and down is on the top in a slope, and the right and left is on the bottom in a slope. So from here, I'm supposed to go down 3, 1, 2, 3, and over to the right, 2, 1, 2. Because it's negative 3, that's down 3, and positive 2, positive x's are over here on the right. Negative x's are on the left. Negative y's are going down on the y's are downward, and positive y's are upward. So this is telling me to go down 3 and over 2, which I do. And I can keep going down 3 and over 2 as many times as I want. I usually like 3 points. Makes it easier to graph. So I'm going to go down 3 and over 2. Okay, So those are the points I mark. I then just draw a line through them and I'm done. Okay, now you try 1 and 2. You can pause the video and try 1 and 2. Okay, next type of problem. Given 2 points, write an equation in slope-intercept form. Now in this case, one of the 2 points is going to be the y-intercept. Well, how do you know which one's the y-intercept? Well, it's the one with 0 for x. If you think about this graph right here, what is the value of x when you're on the y-axis? What's the value of x when you're on the y-axis? It's 0. So if ever there's a 0x, you know that's the y-intercept. So it's giving me 2 points, 2, -5, and 0, 3. Because it's giving me a 0 something, a 0, 3, I know the y-intercept is at 3. So that helps me a lot right off the bat. The next step is to find the slope. So if you have a y-intercept, you're in great shape. And then the next step would be to find the slope. The slope are the subtracted y's over the subtracted x's. If you think about that, going from this point to this point, I would subtract the y's, and then I would subtract these x's. So I just write subtracted y's over subtracted x's. And I can start with either point. Doesn't matter which point you start with. Just remember that the y's come second, and yet you start with those. That's where the mistake is usually made, is kids will put the x's on top rather than the y's on top. Make sure you put the y's, subtracted y's, on top, and then the subtracted x's on bottom. So therefore, I just start with this y and this y. I put the y's on top. -5 minus 3 over subtracted x's. Now, if you start with -5, I've got to start on the bottom with 2. I could have started with 3 on the top, and then I would have had to have started with 0 on the bottom. But in this case, I started with -5, and then I subtract 3. So I'm going to start with 2, which corresponds to -5, and I'm going to subtract the 0. So -5 minus 3 is -8. 2 minus 0 is 2. Those reduce or divide down. 2 goes into 8 4 times. A negative divided by a positive is a negative. So my slope is -4. Now really that means I'm going to go down 4 and over 1 if it's not in fraction form. You'll always go to the right one, down 4 and to the right one. So my equation is y equals -4x plus 3. Now where did the plus 3 come from? That was the y-intercept to start with. Okay? Here's 2 problems that'll give you a y-intercept, and it'll ask you to find the slope to write the equation in slope-intercept form. Here's number 3 and 4. Try doing those. This point is 2, 2, by the way. Try doing those before you go on with the video. Okay, next question. Given the slope and a point, write an equation in slope-intercept form. So here they're going to give you a slope and a point. Now we're going to use the equation y equals mx plus b, the same equation we've been using the whole time. We just need to understand what each of these values represent in the equation. So the x and y actually represent a point on the line. So the x represents the x-coordinate of the point on the line. The y represents the y-coordinate of the point on the line. The m represents the slope, or how far up or down and over you're going to get to the next point. So that's the slope. And b represents the y-intercept, where it crosses the y-axis. Where the x value is 0 is going to be where that is. So the y-intercept is b. Now, to solve this equation, then I simply plug in my point for y and x, and then I'm going to plug in my slope and find the y-intercept b. So I'm going to plug it in. So I'm going to write, okay, I've got 2. You have to, again, remember to start with the y even though it comes second. Again, the way kids usually miss this is they get their x and y in the wrong place. So make sure you put your y first equals slope, -1/2, x times 1 plus b. So I multiply that out. 1 times -1/2 is -1/2. I need to add a half to both sides. Now how do I add a half to 2? Well, I need a common denominator. So I'm going to times top and bottom by 2. That gives me 1/2 plus 4 halves, because 2 times 2 is 4, 1 times 2 is 2. Now I have a common denominator. So 1 half plus 4 halves is 1 plus 4, 5 halves. Don't change the denominator. When you have a common denominator, leave that common denominator in the bottom when you add fractions. So 1 half plus 4 halves is 5 halves. All right, now 5 halves is, if I go 2 into 5, it goes twice with 1 left over. So I'm going to have 2.5. Now, if that is my y-intercept, the point I'd start, I need that in mixed number form. The slope is -0.5. That's plenty good as it is, because I can go down 1 and over 2 on the graph. So the slope leave as a fraction. The y-intercept write in mixed number form if it doesn't come out as a regular integer. All right. Here's number 5 and 6. I give you a slope and a point, and a slope and a point. Find the equation of the line in slope-intercept form, giving those slopes and points. You can pause the video and do that now. All right, next type of equation. Write an equation of a line given 2 points that aren't the y-intercept in this case. So it's going to give you 2 points, no y-intercept, so there's not going to be a 0 for an x. Okay? Now, what you need to do is still use this equation along with the slope equation, which is the subtracted y's over the subtracted x's. You're going to find the slope first. That's going to be your first step. And then you're going to plug in a point, one of these 2 points, for x and y. And then you're going to solve for the y-intercept. Okay, so let's go through those. So first step, find the slope. Second step, plug in the slope and a point and find the y-intercept. Last step, write the equation of the line. So those are the 3 key steps every time. So we're first going to do the first step, which is subtracted y's over subtracted x's. Again, doesn't matter which way you go here. I'm just going from first point to second point, but it doesn't matter. You can do it second point to first point. It doesn't matter. So I'm going to do -9 minus -3. Keep the sign and put it in parentheses when you have minus and negative. Okay? So I'm subtracting a -3. That's important because you'll mess up your signs if you don't do that. Okay, now I'm going to go -1 because I started with -9. I got to start with -1, minusing 1. Notice I wasn't minusing a negative there, so I didn't worry about putting it in the parentheses. Now, what is minus and negative? Well, minus and negative is a positive. So minusing a negative times a negative is a positive. So therefore I have -9 plus 3, which is -6, over -1 minus 1, which is -2. That gives you 3 for the slope. Because a negative divided by a negative is a positive. 6 divided by 2 is 3. Now, that's the first step, was to find that slope. The second step is to plug in one of these 2 points along with that slope to find the y-intercept. The point I'm going to use is 1, -3. The reason I'm using that point is because it's the smaller of the 2 points. It's always going to be easier to multiply by -3 than it is to multiply by -9. So I'm plugging that in. So I'm going to put the -3 in for y. Again, make sure you start with y, which is actually the second coordinate. Too many kids mix up the x and y there. But I'm going to start with y, that -3 equals the slope, +3, times the x, 1, plus b. Multiply that out. 3 times 1 is 3. I'm going to subtract 3 to both sides. -3 minus 3 more is -6. That equals b. Once I have the y-intercept and the slope, I can write the equation of the line. Remember, this is a line is a collection of points on the line. So the x's and y's are exactly what we call them. They are variable, meaning that they can change. You have a whole bunch of points on any given line, and these x's and y values can change on the line anywhere they want. So therefore we leave those as variables because they're going to vary along the points of the line. So we write y equals the slope, 3, times x minus 6. I'm going to start at -6 on the y-axis, and from there I'm going to go up 3 and over 1, and that would create a whole bunch of points on the line, 2 of which are -1, -9, and 1 and negative 3. Now you try 7 and 8. Write me an equation of a line given these 2 points for 7 and 8. Remember, you're going to find the slope first, then you're going to plug in the slope you get with one of these points. I would suggest you use 2, 1 because it's easier. And then you're going to solve for b, and once you've solved for b, write an equation of the line. Okay? You can pause it here if you want to do those 2 problems before you move on. All right, the next type is going to be determining which lines are parallel, perpendicular, or neither. Okay? Remember on this part, the parallel lines have the same slopes, and perpendicular lines have opposite reciprocal slopes. So this symbol means parallel, this symbol means perpendicular. Now, what do I mean by opposite signs and reciprocal slopes? Well, if I have 3/5 as my slope of the original equation, this is the slope, my perpendicular slope, the slope of a line perpendicular to it, would be -5 over 3. Notice this was positive, this is negative. The reciprocal of 3/5 is 5/3. So it's the opposite sign, positive to negative, and reciprocal slopes. These would be perpendicular slopes. And really that's what you care about when you're determining whether lines are parallel or perpendicular. You care about the slopes. So we're going to start with this example. So we're going to start with number 1. The first equation is given. Once you have that first equation, you've got to compare it to 2 other lines, okay, and see if this original line is parallel or perpendicular or neither to any of these 2 lines. So let's first do this one. So we have a line that's going to pass through the points 5, 6, and 1, -2, and we want to know whether it's parallel, perpendicular, or neither to this equation, 1/2 x plus 5. So we set up our slope. Again, subtracted y's, put the y's on top. 6 minus -2 over subtracted x's. If I start with 6, I got to start with 5. 5 minus 1. 6 minus -2, negative times a negative is a positive. 6 plus 2 is 8. 5 minus 1 is 4. 8 over 4 is 2 over 1. Now look back at the original on number 1. I have 1/2 here, I have 2 over 1 here. Are those reciprocals? Yes. But, and this is the important part, do they have opposite signs? This is positive, but this also is positive. Therefore, these are not perpendicular. Yes, they have reciprocal slopes, but they are not opposite signs. So therefore, these are neither. They look perpendicular, but they weren't. Okay? Now, number 3. The third one. We're still comparing it to the first one every time. So we're going to find a line passing through these points. Now notice I don't even have to find the whole equation of the line. I'm really just looking at the slope. So again, I subtract the y's over the subtracted x's. Again, I start with 1 minus 3 over, and now I have -3 minus 1. 1 minus 3 is -2. -3 minus 1 is -4. A negative over negative is a positive. 2/4 reduces to 1/2. So the slope of this line is 1/2. The slope of the original line was 1/2. Therefore, we know these 2 lines must be what? Parallel. Okay? Now you try number 9 right here. Starting with this equation, y equals -3x plus 4. Compare it to the equation x equals 3y, or x plus 3y equals -3, and a line that passes through these 2 points, 5, 2, and 4, 5. Tell me if 2 is parallel, perpendicular, or neither, and tell me if 3 is parallel, perpendicular, or neither to the first equation. You can pause it and try that on your own if you want. All right, next step. Write the equation of a line that is parallel and perpendicular passing through a given point. So this time they're going to give you a point, and they're going to give you a line, and then they're going to want you to write an equation of that line that will pass through the point and be parallel and perpendicular, so you're going to have 2 answers for each of these, to the given line. So first of all, I'm going to do parallel. Now remember, parallel is going to have the same slope. So the slope of this is -1/2. I'm going to use -1/2. I'm then going to plug in my point. Again, I'm just using y equals mx plus b. I use that equation over and over and over again on this whole entire test. So get used to what those letters represent. Again, the x and y represent points on the graph, the m is the slope, and the b is the y-intercept. You need m and b to write the equation, okay, of any line. So, again, I plug in the point, 4, remember to put in the y first, equals, and then I put in the slope, -1/2. It's exactly the same because it's parallel, so I'm doing parallel first. I put in -1/2. I put in my x value, -2, plus b. Well, the 2 divides out the 2, so that's going to divide out. That's going to give me -1. That's going to give me 1 there. What's -1 times -1? Make sure you multiply here, don't subtract. I have some kids write -2 here. But remember, it's a -1 times a -1. -1 times -1 is +1. Subtract 1 from both sides. B is 3. Oops, sorry, I didn't circle that good. So B is 3. So now I'm going to write the equation with B being 3 and the slope being -1/2. Same slope because we're talking parallel lines. So the parallel line that passes through this point, -2, 4, will be y equals -1/2x plus 3. I would start at 3 on the y-axis, and I would go down 1 and over 2 to the right, and I would have a line that is parallel to one that started at 5 and went down 1 and 2 to the right. Notice these two lines are parallel. They have the same slopes with different y-intercepts. Those are going to be parallel. Okay, now we want one that's perpendicular, passing through the same point. So now instead of drawing one that's going to be, so two lines that were parallel, I now want one that's going to come down perpendicular, okay, meeting at a right angle. So to do that, I simply take the opposite reciprocal slope. So instead of -1/2, what would the opposite sign and reciprocal slope of that be? Correct. The perpendicular slope is going to be 2, or 2 over 1. So I'm going to use this perpendicular slope of 2 as I write the equation of the line. Still using this point for -2. So I'm going to put in the 4 for y, the 2, which is my perpendicular slope, for m, the -2 for x, plus b. Remember, the m and the x get multiplied. Don't add those. That's, again, a mistake a lot of kids make. You've got to multiply the m and the x value. So I've got to take 2 times -2, which is -4. Add 4 to both sides. 4 plus 4 is 8. That's going to be my b, or my y-intercept, value. Therefore, a perpendicular line would be the equation y equals 2, that's the perpendicular slope, x, plus the y-intercept, that's the b value, 8. Okay, try these two questions then. Number 10, passing through the point 4, 1, and parallel and perpendicular to this line, y equals 1/2 x plus 9. Again, passing through the point -3, 2, parallel and perpendicular to this line, y equals -x plus 7. Try both of those. If you need to pause the video, do so and try those two. Okay, next question. Write an equation of best fit for the data points. Explain what the what the slope and y-intercept represent. So here we have a golfer's handicap. And here we have the years that player has been playing. So it has a whole bunch of data points. So some people obviously had higher handicaps than others after the first year, and we just dotted a lot of different people whose handicap was something after a certain number of years. They're all over the map with these dots. We're going to draw a line of best fit. Now remember, you're supposed to have about the same number of points above it as you do below it. But the most important thing is pick your points wisely. So I've already picked the points for you on this one. And I went over 2, and I went up 22. So this point is 222. And then this point was over 4 and up 18. So 418 is the points I picked. Pick points that are actually on integer values. So don't pick like, I could have picked here 2 and say, because these, I might have wanted it a little steeper to get through these points. I could have picked like 2 and 22 and a half. But don't pick points that are that way. Don't pick values that are going to be, decimals or fractions. Pick integer values. At this point, once I picked my 2 points, now you can figure out the equation of best fit. So I'm going to now write an equation by first finding the slope. That's going to be the first step. And then plugging in a point, one of these 2 points I picked. Don't plug in a data point. Plug in one of these 2 points you've picked, which may or may not be a data point. And then once you've done that, once you found the slope, plug in one of the points with the slope and find the y-intercept, and then write the equation of the line. You'll notice we've done that quite a bit. Find slope first, given 2 points, then plug in the point, one of the 2 points, and the slope to find the y-intercept, the b value, and then finally writing the equation y equals mx plus b with the slope and the y-intercept in the equation. So I'm going to walk you through that. So first of all, I'm going to do 22 minus 18. Remember to put the y's on top. Over 2 minus 4. Put the x's on bottom. If I start with 22, I've got to start with 2, which I did. 22 minus 18 over 2 minus 4. That's going to equal 22 minus 18 is 4. 2 minus 4 is negative 2. 4 divided by 2 is 2, but a positive divided by a negative is a negative. Therefore, my slope is negative 2. I'm going to plug that in with a point. Again, I'm going to use the smaller of the 2 points, which is 222, smaller being the smaller x. Just makes it easier. So I'm going to put in y is 22 equals negative 2 times x, which was 2. Remember, I'm using this point, 222, 22, 2, plus b. Again, multiply these, don't add or subtract them. So I'm going to multiply negative 2 times 2 is negative 4. Add 4 to both sides. 26 is b. So therefore, y equals negative 2x, that's the slope, plus 26. Then it asks this part, and this is super important. Explain what the slope and the y-intercept represent. So think about this. What does the y-intercept 26 represent? That's saying the average golfer or most golfers start with a handicap of 26 over par. In other words, if par is 72, their typical round is going to be pretty close to 100, like 98. Okay. Now, once you get better, you're going to get better by 2 strokes per year. That's what it says. Most golfers' handicap goes down, that's the negative 2, by 2 strokes per year. That's what the slope represents. So therefore, we're getting 2 strokes better every year. Okay, that's what the data shows. Now, you try this one. Speed of a pitch, age of the player. So again, we have some 5-year-olds, they're maybe throwing 20 miles an hour, maybe some 30, who knows, all up in here. And we have, as they get older, we have all these points of kids and whatever, we don't really care, they're just throwing the ball. And we are trying to pick a point that, again, tries to get as many high and low as we can, but falls on an integer value. So I chose the point 1050, meaning at 10 years old, most players who are playing baseball are throwing around 50 miles an hour. And when you're 20 years old, most people can throw about 75 miles an hour, as long as nothing went wrong with their arm or anything like that. So, using those 2 points, write me an equation of the line and explain to me what the slope and y-intercept mean in that equation. You can pause it and do that now if you want. All right. Last type on this test, which is arithmetic sequences. This is the key equation for arithmetic sequences. Have this in your notes. A sub n equals a sub 1 plus n minus 1 times d. This d is the common difference, or the amount you're going to add or subtract to get to the next value. The n is the term that you're trying to find. So if you're trying to find the 35th term, n would be 35. If you're trying to find the 40th term, n would be 40. Ace of 1 is the very first term in the sequence. Okay? And then ace of n is the value of the nth term. That's what you're going to end up equaling when you're done. Okay? So, arithmetic sequence, find the 35th term in the sequence and the next three values in the sequence. That's what I'm going to ask you to do on this one. Now, I did a really hard one. I'm going to give you easier ones, and it isn't really super hard anyway, but I started with negative 16 thirds. I then went to negative 10 thirds. I then went to negative 4 thirds. Now, what are you adding to each value? Or subtracting from each value? How did you go from negative 16 to negative 10, negative 10 to negative 4? So if you're saying, okay, I added 6. Well, really you added 6 what though? 6 thirds. If you're unsure of that, you can always just take the second term minus the first term. So if I take the second term, negative 10 thirds, minus the first term, which is negative 16 thirds, so minus a negative is a positive. Negative 10 thirds plus 16 thirds, negative 10 plus 16 is 6, over 3. So really you're adding 2 or 6 thirds every single time. I'm going to use 6 thirds because all these denominators are thirds. So I want to use 6 thirds as what I'm adding every time. So that's really easy to figure out. I just add 6 to negative 4, so think about being on a number line. If you're at negative 4 and you move 6 to the right, where are you going to be? 2 thirds. Add 6 thirds more, so 2 plus 6, that's going to be 8 thirds. Add 6 thirds more, 8 plus 6 is 14 thirds. So those are your next three terms. So that isn't very hard. Once you have the common difference, it's easy to find. Now, you could keep adding and adding until you get 35 terms out here, but that's going to take forever. So it's much easier to use this equation to find the 35th term in the sequence. So I'm just going to substitute in ace of 35, meaning I want to find the value of the 35th term, equaling the first term, that was the negative 16 thirds, plus n minus 1. So I'm trying to find the 35th term, so 35 minus 1 would be 34. That's how I got the 34. Again, it was 35 minus 1. That's how I got the 34. Times d. This is the common difference. I could use 6 thirds in here if I wanted, by the way, and it would still work out fine. I just threw in a 2 because 2 times 34 I can do in my head. So 2 times 34 is 68. Now I'm going to change that by timesing top and bottom by 3 so that I have a common denominator. 3 times 68 is 204. So I have 204 thirds plus negative 16 thirds. That's so I have a common denominator. Now I just take 204 minus 16, that's 188 thirds. That's where I'm at. So if I go out 35 terms, keep adding 6 every time, I'm going to end up at 188 thirds when I get to my 35th term. So that's what I want you to do for 13 and 14. Tell me the common difference. Tell me the next 3 terms in the sequences. Common difference, next 3 term in the sequence. Then I want you to find the 35th term for both 13 and 14. The last question is a little bit of a story problem, but it deals with this same application. So I'll just read it to you. It says, an auditorium has 40 seats in the front row. Each row, 2 seats are added, 1 on each end. Okay? So we're adding rows, so the auditorium looks kind of like this. We have 40 in that first row, and then it kind of starts going up like this a little bit. Adding 1 seat on each side of the row, right? So this has 40, the next row would have 42, and you can keep going up, okay? So each row, 2 seats are added. If there are 31 rows in the auditorium, so I can go back 31 rows in this auditorium, how many seats are in that 31st row? That's what it's asking. Okay, try all those, and then you should be ready for the test tomorrow. Thanks. Bye.